right, home plate for tonight, pages 564 and 565. We're going to do all only. It's only 10 problems. Only. And make sure you graph numbers 1, 2, and 5. Also. Once again, pages 564, 565, and you're going to graph only numbers 1, 2, and 5. And I know the book does not ask you to do that, but I'm asking you to do that. All right, we're good? Yes, Mr. Q. All right, good. Our objective for today, I can solve radical equations. I can solve radical equations. Pretty much today is the foundation for radical functions. It's pretty much about the same thing. It's going to transfer over. That's why I'm going to be using interchangeably f of x instead of y on the equations and functions. Okay? Once again, our objective for today, I can solve radical equations. Radical equations. What are radical equations? Radical equations are an equation whose rule contains a variable under the radical symbol. Radical equations, an equation whose rule contains a variable under the radical symbol. Radical equations are obviously an equation, but what's the particular about that? Whose rule contains a variable under the radical symbol. Okay, that makes sense. Examples. Y equals square root of x. 8 times square root of x equals y. Y equals square root of 2x plus 1. And y equals 3 times square root of x over 2 minus 6. Let's see, according to the definition for radical equation says that it has to be an equation. Do we have equations? Yes, they're all equations. What is the second thing? It contains a variable under the radical symbol. Let's look at the radical symbol here. Does it have a variable underneath? Yes. This one, yes. This one, yes. And this one, yes. Okay. So that's why those are radical equations. All right. Non-examples. Square root of x, y equals x plus square root of 16, and the last one is negative 3 plus x equals 10. As you're copying those down, think about it. Why are these not radical equations? As soon as you copy those down, share with your neighbor why each of these are not radical equations, please. Copy that and go. All right, let's see. Cindy, the first one, why is this not a radical equation? Because it's not an equation. This is a radical what, everyone? Expression. That is correct. Pass someone. Danica, why is the second one not a radical equation? The variable isn't under the radical. That is correct. And the last one, everyone, why is this not a radical equation? There is no radical, all right? So let's try some hashtags there as to what makes a radical equation a radical equation. Hashtag, what are you guys doing? Tweeting or snapping or Instagram? What are you guys doing now? Snapping, WhatsApping, kicking? Man, there's so many TikToking. What are you guys doing now? Hashtag what? Anthony, go. Variable under what? Radical. All right, pass someone. Bree. Equations. That pretty much sums it up, yes? Okay. Damn, let's go. All right. So, look up, guys. Students, General rule of transformation again. Welcome them back. Anyways, by now we don't need to write it down because by now this should be like in our noodle by now, right? You wake up like, g of x equals. Anyways, tell your neighbor what each piece of this transformation rule does to any transformation, any function, to any function. What does it do? What does it do to any function? All right. Very good conversations. Let's start with Roman McGuire. What does K do? Hands if you agree that it moves it. Oh, hands agree if it moves it up and down? Yes. How about H? Left or right? That is correct. Pass someone. Colton, what does A and B do? Stretch or compress. However, the A stretches it and compresses it which direction? Vertical, and the B stretches it and compresses it horizontally. That is correct. Okay. Now, we don't need to write that down because we know that by heart now. Okay? So I'm going to do a recap. Look up, please. This is where we've been again. I keep going at it again to make sure if you missed it last time or if you were distracted by your neighbor, not you, but your neighbor distracted you. Here it goes. F of x equals x. We've been there, yes. F of x equals x squared, is that correct? F of x equals x cubed, yes. F of x equals absolute value of x. And then we got to rational, which is f of x equals 1 over x. And nothing there with a lot of transformations. So, let me remind you what each one of those graphs look like. Once again, I'm going to start with this one, which is the latest one we did. It looks something like this, with asymptotes. Is that correct? So that one is that. However, if I was to rewrite this with transformations, it would look something like this. G of x equals 1 over x minus 3 plus 5. Tell your neighbor what it's going to happen to this whole function, including the asymptotes, according to those transformations, please. Go. All right. Who said 3 to the right and 5 up? That is correct. The whole thing moves 3 to the right and 5 up. However, what happens after they move that and if it has a negative, everyone? It flips or it reflects about the horizontal asymptote or axis. Okay. From there, here goes the graph for this one. It looked like a what? A V. There's the absolute value. And once again, I give you guys with transformations such as g of x equals absolute value x plus 4 minus 2. Tell your neighbor what's going to happen to the entire V according to that transformation. All right, good. Roberto, what's it going to do? Victor, help him out. 4 to the left and 2 down. Hands if you agree with that. That is correct. From there we go to a cubic function. It looks like this. And if I gave you the transformation, it would look like this. G of x equals parentheses x minus 1 cubed plus 7. So you know what's going to happen to the entire function according to that transformation. All right. Bea, what's going to happen? 1 to the right and 7 up. Hands if you agree with that. Yeah, so far so good, yes? You're like, Mr. Q, now it's making sense after like 1,000 times. All right, here we go. This one looks like this. It's a parabola. Yes? 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, and so on. And if I gave you the transformation that looked like this, g of x equals x plus 3 squared minus 5. Tell your neighbor what's going to happen to the entire parabola, please. All right, Mel, what's going to happen to the entire parabola? 3 to the left, 5 down. Hands if you agree with that. Okay, good. Now look at this last one and be careful with this last one. First of all, let me point this out. Look up, please. We are able to define the transformations because we see the grouping symbols. Do you guys see the grouping symbol here? Here, here, also here. Yes, the fraction bar serves as a grouping symbol. Okay, let me do the last one. The last one's a linear function. Here, there's a line. And let me show you a transformed linear. G of x equals x plus 3. Look at it. Tell your neighbor what's going to happen to the entire function according to that transformation. Go. Good conversation. Let's see. Damon, what's going to happen to the entire linear function? Okay. Hands if you agree with that. Close, because this one does not have a grouping symbol. What does that mean, Mr. Q? That means that the x is by itself. So what's outside of the x? The plus 3. So what is the plus 3 going to do? Move it up. This is the only one that it looks like it's going to go to the left, but it's not. This one's going up. Tell your neighbor why this one is different from all the other ones, please. Talk it over to your neighbor. Why is that one different from all the other ones? All right. All right. So, we're good, right? All right. Well, students, radical functions, students. All right. So here we go. Writing utensils down. Let me show you the parent function of all the radical functions that we're going to do. This is the original one, the OG, the very first one we're going to start with, okay? F of x equals square root of x. So here we go. What does that look like, Mr. Q? Let me show you. X, f of x. Now the domain is going to be a little bit different on this one because I want numbers that I can find, pay attention to this part, the square root of without falling into decimals. Let me repeat that again. I want x values that I can find square roots of without going into decimals or estimation. So the first value I'm going to use for x is 0. Because if I substitute that in there, what is square root of 0? 0. The other easy number that I can pick from x is what? 1. Because if I substitute that in here, what is square root of 1? 1. Now, I'm not going to choose 2 because I would end up with what? Square root of 2, and then I'll have to do the, it's in between 1 and 4, and then do the whole, you see what I'm saying? I'm not going to do 3 because I'm going to fall into the same thing. What is my next value? 4, because what is square root of 4? 2. What would be the next value after that? 9, because square root of 9 is 3. But for right now, the only 3 I'm going to use from this point forward are 0, 1, and 4. That would give me what? 0, 1, and 2. So check this out. Let me plot that. 0, 0, 1, 1, 4, 2. And this is what the radical function looks like. Students, radical function, students, copy that, please. Now that you copied that one, underneath you wrote f of x equals square root of x minus 2, and then outside the radical we have plus 3. Bless you. All right, so check this out. Bless you. Let me update my graph here since I moved screens. So check this out. I'm going to graph the original or the parent function again in blue, this one. Not even going to use a table. I know it's what? 0, 0, 1, 1, and 4, 2. That never changes. Tell you never what I just said again. Okay, there it is. However, now I want to transform that one according to this. And I'm going to do that in red. My transformation I'm going to do in red. Before I do the transformation of each of those points, tell you never what that's going to do to the entire function. What is it going to do to the entire function? Go. All right, let's see. Rosina, what is it going to do to the entire function? Move it 2 to the right and 3 up. Hands if you agree with that. That is correct. I start with this point. At 0, 0, I'm going to move it 2 to the right, 1, 2, 3 up, 1, 2, 3. And there's my new point. I'm going to move this point 2 to the right, 1, 2, 1, 2, 3. And this one, 1, 2, 1, 2, 3. And there's my new function. Yeah, we got this, right? Can we return function here with this? Yeah, we got this. All right, so now that we did a good introduction to graphing and transformations, now we're going to combine it. Now we're going to do one where we have to graph, and then we have to solve the function. Okay? Y'all ready? Crank it up. Allie, yeah? You said yes, that she's excited to go to the next problem. All right, let's go to the next problem. Here we go. Example number 1. Solve and graph f of x equals square root of x minus 3. And then outside the radical, we have minus 1. Copy that. So, like in the home plate, which problems are you going to graph? 1, 2, and 5. The first thing I want you to do with all these that you have to graph the parent function first. So even though it's not here, I'm going to write it over here on top. F of x is what? Square root of x. And I'm going to do that in blue. How does that look like once again? Let's see, Cindy, give me the points for that one. Damn, Cindy, let's go. There you go. All right. And now I'm going to graph the transformation. Pass someone. Allie, what are we going to do with that? 3 to the right, 1 down. So I go 1, 2, 3, 1 down. 1, 2, 3, 1 down. 1, 2, 3, 1 down. And there's my new function, transform. Are we done with graphing? Yes, Mr. Q, we're done with the graphing portion. All right, let's focus on the solving. All right, let me zoom in. Writing utensils down, look up to the screen. I'm going to go over this one completely, and then I'll give you one for you to do the solving portion. Okay, here we go. Writing utensils down, look up to the screen. Here it goes. With any function that we've been working with, what is the one thing that they all have in common that we need to equal it to what? 0. That is correct. So that means I'm going to change this. Instead of changing it to y, I'm going to skip that step and change it to 0. So this is 0 equals square root of x minus 3. And outside the radical, I have minus 1. Step 2, just like any other function, the second step is the same. We need to isolate the grouping symbol. Kind of like when we did absolute values, we isolated the absolute values. You guys remember that? So here we need to isolate the radical, which is here. So what's outside the radical? The -1. So what do? Add 1, add 1. I end up with 1 equals square root of x minus 3. From there, I need to continue solving, which means leaving x by itself. How do I get rid of this square root, everyone? What is the inverse? Square it. That is correct. And whatever I do to one side, I do to the other side. This cancels this. I'm left with x minus 3. And on the other side, I have 1, because 1 times 1 is 1. And finally, just solve for x. Add 3. Add 3. 4 equals x. And that's how you solve radicals. Copy that, please. All right, so the whole thing should look like this. We have the original parent function in blue. The transformation was done in red. And then from there, separate from that, we did the solving. First step was set it equal to 0. Second step, isolate the radical. And third step, just solve for x. Straightforward, yes? Yes, Mr. Q, we love these. All right, good. Go to another one. Copy that one. We got example 1Q, solve and graph. I want you to start with the graphing portion first. Remember, graph the parent function and then with a different color, graph the transformation, and then go to the solving portion. We are given f of x equals square root of x plus 2 minus 4. Copy that and go. Check your work. 14 equals x. Hands if you got that. That is correct. And it went what? It went down 4 steps and 2 to the left. Everybody see that? All right. Okay, show me what famous outcomes you are with these. Yeah, okay. Now check this out. Don't copy this next one. But look at the new function. F of x equals square root of x minus 7. And then outside the radical minus 9. Tell you never what would happen to the function according to those transformations. Fernanda? 7 to the left and down 9. All right, we got this, yes? All right. Shall we? Let's crank it up. Woo, let's go. Copy that one. It reads, example 1 super Q, solving graph, f of x equals square root of 2x minus 8 minus 16. Now, check this out. Before you start graphing, look up, look up. The obvious one is this one, is that correct? That tells us to go down how many steps? 16. The one that's not that obvious, or should raise a red flag, is this. Look at it. What's so different about that one from the previous ones? Tell your neighbor, please. Yeah, this one has a what? A coefficient. Can we factor out a GCF, or can we set it equal to 0 to solve for x? Yes. What would be easier? GCF. So what is GCF? And we're left with x minus 4. So what would be my transformation? 4 to the right. That is correct. 4 to the right. Or in other words, you can set it equal to 0. 2x minus 8 equal to 0. Plus 8 plus 8. 2x equals 8. Divide by 2, divide by 2. X equals 4. So that means 4 steps to the right and 16 down. Okay? Now, that's just for the graphing portion. How about for the solving? We set it equal to 0. What do we do next? Add 16, square root, square it, and so on and so forth. Okay? Just copy that. Don't copy the whole thing. I'm just showing you the piece that was different from the others. But the rest is the same process. You guys see it? Yes? Good. All right. Now that we're done with the easy ones, let's go to the funner ones. Yes? Let's go. Woo! Copy this one. Example 2. Example 2 says, solve and check your answer. Parentheses, x plus 6, close parentheses, to the half power, minus, open parentheses, 2x minus 4, close parentheses, to the half power equals 0. Now, since you've been doing your home play, this should be a piece of cake, okay? So here we go. Writing utensils down, look up to the screen. I'll do the first step, and you should be able to follow along in your Moodle. Then after that, I'll have you copy it and finish it off. So look up to the screen. Step 1 is always set it equal to 0. Is it already set it equal to 0? Yes, check. Step 2, isolate the radical or the grouping symbol. So first, do we have radicals? Do we have radicals? Yes, this is a half. That becomes what? Square root of x plus 6 minus, what is this? Square root of 2x minus 4, and all that equal to 0. What is step 2? I need to isolate the radical. Same. They're all on both sides. I'm saying the radical, one radical. So that means I need to get rid of this one. What do? Add square root of 2x minus 4, add square root of 2x minus 4 to each side. All right. This cancels. We're left with, I'm going to bring down this one, square root of x plus 6 equals 2. What do I have on this side? Square root of 2x minus 4. From there, do we have them isolated? Yes. How do I cancel the square root? Square it, and whatever I do to one side, I do to the other. So this cancels that. We're left with x plus 6 equals 2x minus 4. Does this look familiar? Yes. Copy that and finish it off, please. I'm going to zoom out. All right, so if we continue from here, I need to solve for x. What do? Minus x minus x. I got 6 equals x minus 4. And lastly, plus 4 plus 4, 10 equals x. Show me with your fingers how comfy you are with these. Yeah, we got these, right? All right. However, that says to solve. What do we do to check? Tell you never what you would do with that value in order to check. Everyone? Substitute. So basically I would do this. I'm going to change this from half to a radical, and it would be x plus 6, so it would be 10 plus 6 minus radical 2 times 10 minus 4, and all that should equal to 0. So this is square root of 16 minus, this is 20 minus 4, that's square root of 16 equal to 0. So what is this, a 0 pair? Is 0 equal to 0? Yeah, check. And that's how you check. Piece of cake? Yes? All right. So what does it look like this, though? Look at this one. Let me get you started. Look at it. Chelsea, what would I do? Isolate the radical, so subtract 2 to each side. We end up with square root of x plus 10 equals to x minus 2. And then, how do we get rid of this radical? To the second power, to the second power. This cancels that, so I'm left with x plus 10 equals to this squared. That becomes x squared minus 4x plus 4. Does everybody see how I got this? Yes, x minus 2 times x minus 2. And then, set it equal to 0, right? minus x minus 10 minus x minus 10. 0 equals x squared minus 5x minus 6. And from there, the rest of it is history, yes? Does that look familiar, guys? Like when we've been solving quadratics already? Negative 6, negative 5. Factors of negative 6 that add up to negative 5. Negative 3 and negative 2. No, that doesn't work. Negative 6 and 1. Negative 6 and negative 1. And I'm just going to use a shortcut. 0 equals parentheses x minus 6, x minus 1. Set it equal to 0. Oh, plus 1, my bad. Plus 1. Plus 1. X minus 6 equals to 0. X plus 1 equals to 0. So therefore, x equals to 6. X equals to negative 1. Okay. Now, in the previous class, somebody said, Mr. Q, but what if we have a cubic? Damn. Woo! Let's go. Let's see, help me with this one. I'm just going to pick someone at random. Cindy. All right. Line down the equal sign. What do? Minus 7 minus 7. Cube root of x plus 2 equal to negative 2. How do I get rid of that cubic or cube root? To the third power. This cancels that. X plus 2 equal to negative 2 cubed is negative 8. Is that correct? And lastly, minus 2 minus 2. X equals negative 10. As soon as you copy that, log out. Show me your parents have come through with these. Yeah, we got this. Yes? 4 5? 4 5? Yes? Cindy says 10 over there. Bam. Good one, guys. Enjoy your home play. See you guys tomorrow. Reminder, retakes during lunch today and tomorrow. Tomorrow's Friday. Don't forget what we have on Friday. Woo! Let's go. Good one. See you guys tomorrow. Bye.